structure and the electron configuration, which is our next topic in Unit 2. For this one, we're going to be focusing on the Bohr's theory of the atom. There are many theories about the structure of the atom, and Bohr's is perhaps one of the most used ones, but it doesn't mean it is the correct one, but it's the one that we use to explain the basic structure of the atom. In advanced chemistry courses, you're gonna see other models of the atoms. But in this one, Bohr, we're gonna call it the planetary model. The planetary model because it is similar to the solar system, where the sun is in the center and the planets orbit around. In this case, the nucleus is at the center, as you can see right here, and the electrons orbit around. They orbit around in orbits, of course, that we call energy levels or shells. These shells, they do have different energy levels. The closer the shell is to the nucleus, the more energy, the less energy they have. The farther away they are from the nucleus, the more energy they have. Here we have it in this statement. Shells which are further from the nucleus have higher energies. When we just complete this with electrons, is what we call the electron configuration, is the distribution of electrons in energy levels. So we're going to be using a very simple electron configuration of 2, 8, 8, 2. That means that energy level 1 can have a maximum of 2 electrons, energy level 2 a maximum of 8 electrons, energy level 3 a maximum of 8 electrons, and energy level 4 it is a maximum of 2 electrons. That is the only electron configuration that we're going to be using now. There is something more, a little bit more complex, but then you're going to see it in IB chemistry. Let's continue with this one. Here, these are the only atoms that you're going to be drawing for this electron configuration. So in the questions that you're going to have about the model of the atom and the electron configuration, you may be asked to draw a model or write the electron configuration of the atom, the neutral atom, or the ion. And only for this extended chemistry class, you're going to be using the first 20 elements, no more. So what do? The first thing that you got to do is draw a simple nucleus, as the one that we have right here, indicating the number of protons. The neutrons is optional if you're being asked, but essentially you need to include the number of protons because that's what's going to tell you the atom we're talking about. The next thing that you do is fill in the atoms or energy levels with the electrons. Remember that we're going to be using the rule of 2, 8, 8, 2 as the maximum. You can have less than the maximum, but if you need more, you need to move on. And the maximum number of electrons that you will distribute will be 20. And then you continue distributing the electrons until you finish all the electrons that you have to distribute in total. Let's see this example. Let's say that you need to draw an atom of aluminum. So you find aluminum in the periodic table and see that it has an atomic number of 13. So that means that it has 13 protons. So if it has 13 protons, that means that you need to distribute 13 electrons in total. So how do you do it? So you just follow the sequence 2, 8, 8, 2 until you complete 13. So you have 2 maximum, then 8, that's going to give you 10, and it's also a maximum, but you still need 3 more. So you just move on and do 3. So that means that this atom has 3 energy levels. In the first energy level, it has 2 electrons. The second energy level, it has 8. And in the third energy level, it has 3 electrons. So you just do it like this. You distribute the electrons. You can do it like far from each other, or you can draw these in pairs. In this case, you have 2. Then you have here 8. And then you have 3 in the outermost. If you're going to draw the electron configuration of the ion, in this case, the ion of aluminum is 3 plus, so that means that it has lost 3 electrons. So it has lost 3 electrons, so you remove the 3 electrons, and in this case you have only 2 and 8. The ion in this case shows that it has lost 1 energy level, so you only draw the first and the second, but still it is the same aluminum because remember you have the 13 protons. That is one of the examples. Let's see another example. In this case is potassium. Potassium has 19 19 protons. So you have 19 protons. So that means that you need to distribute 19 electrons. So how do you do it? Energy level 1, 2, 8, 8. That's the maximum. So you have 2, 8, 10, and 8 is 18. So you need one more. So 19. So in this case, you have 4 energy levels or 4 shells. 1, 2, 3, 4. The first one you have 2, in the second 8, in the third 8, and then finally you have 1 electron. For the ion is +1, so that means that it has lost 1 electron, so it means that it loses this electron right here. So you just draw 3 energy levels, but still it has the same number of protons. That's one more example. So let's see one more example. When you have, let's say they say you need to draw the ion of Cl -1 or chloride ion. So what you have to do is first find chlorine in the periodic table and then see that it has 17 protons. So this element has 17 protons, but it has a charge of -1. -1, remember that it's an anion, which means that it has gained an electron. So that means that if you originally had 17 electrons with a charge of -1, now you're going to have 18 electrons. So that means that you need to distribute 18 electrons. So that means it's 2, 8, 10, and 8 more. That's 18 electrons. So here, this is chlorine. As you can see, chlorine has 17, the neutral. But since you're not being asked for this, but this one, so you need to have one more electron. So usually the ions, we draw a square parenthesis and we put the charge outside, indicating that it has gained 1 electron. This one here shows that you have gained 1 electron. This one, as you can see, compared to this one, it has gained one electron. So let's do this one more time. Okay. Lesson check. The diagram, this diagram shows the arrangement of electrons in an atom. So we have 2, and here we have 3, 5, 8, and we have 1 here. So we have a total of 8 electrons. So what is the correct electron configuration? So in the first energy level, we have 2. In the second energy level, as you can see, we have 8. And in the third energy level, we have 1. So we don't have a fourth energy level, so we don't have to draw this one. So this would be the electron configuration for this element 281, which is sodium. Let's see here. Remember that this is the electron configuration of the first 20 elements. And you need to remember is the 2882. Remember that the maximum that we're going to do is 20, and this is the maximum number, but these are all of the atoms that you will be throwing through these 2 years of chemistry.